A very good morning, dear students. This is chapter 13, Magnetic Effects of Electric Current, and this is part 5 of the chapter. Okay, so let me show you what we are going to discuss today in this session. In this session, we'll discuss electric generator. What is electric generator? On which principle does it work? And what is the use of electric generator? All these points today we are going to discuss in this session. So let me start here. Electric generator is the mechanical device that converts mechanical energy into electrical energy by rotating a conductor in a magnetic field. If you remember, we discussed about electromagnetic induction. In electromagnetic induction, we rotate electrical conductor in magnetic field and electricity is produced. The same principle is used over here in electrical generator. In electrical generator also, an conductor is rotated in a magnetic field. Okay, and electricity is produced. Here in animation you can see that this conductor is moving inside the magnetic field and electricity is being produced. And the presence of electricity can be noticed in this galvanometer. You can see the needle of galvanometer is deflecting when electric coil is moving inside the magnet. If electric coil is not moving, you just now observe, if electric coil is not moving, deflection is not there in galvanometer. But when electric coil is moving inside the magnet, electricity is produced, right? These are the magnets. Okay. Okay. So now let me discuss the construction of an electric generator. Electric generator consists of a rotating rectangular coil ABCD. Okay, this is this A, B, C, D. This is the coil. Okay, actually let me rub it so that it can be clean and I can explain you easily. So electric generator has a coil ABCD. This coil is placed between two poles of permanent magnet, North Pole and South Pole. Okay, the two ends of this coil are connected to two rings R1 and then rings R2. Okay, the inner side of these rings are made insulated. The two conducting stationary brushes B1 and B2 are kept and they are pressed separately on the rings R1 and R2. These two rings R1 and R2 are internally attached to an axle and the axle may be mechanical rotated from outside to rotate the coil inside the magnetic field. Okay, outer ends of two brushes are connected to the galvanometer. Here you can see these outer ends are connected to the galvanometer. Okay, see. Okay, and it will show the flow of current in the given electrical circuit, right? Now working of electric generator. When the axle attached to the two rings is rotated mechanically, see, this axle will be rotated mechanically. ऐसे इसको हम mechanically घुमाएंगे. Okay, at first let me make it clear. Erase everything. Right. So now what will happen? See, such that the arm AB it will move up. ठीक है? And arm CD is moving down in the magnetic field that is produced by permanent magnets. That is magnetic field, north to south, that you know that the direction of magnetic field is from north to south, and that is our coil. And here the current is flowing in this direction. Okay, now suppose ABCD is rotating clockwise, and the arrangement you can see in the picture. Now by applying Fleming's right hand rule, The induced currents are set up in these arms along the directions AB and CD. Okay, so thus an induced current flows in the direction A, B, C, D. Okay, if there are larger numbers of turns in the coil, then what will happen? The current generated in each turns adds up to give a large current through the coil. This means that the current in the external circuit flows from B2 to B1, right? So now what will happen after half rotation? This arm CD, this will start moving up, and this arm AB, this will start moving down. This AB and that CD. After half rotation, what will there? This AB will come over here and the CD will go over there. Okay, and now AB will go down and CD will go up. Okay, and this way this process will be continued and electricity will be produced continuously. So this type of current that changes the direction after equal intervals of time is called an alternating current, or we can write it AC also. And this type of generator that produce this type of current are known as AC generators. Okay, you can see after each half rotation the direction of current is changing. Okay, now here the working of electric generator. At first, let me rub all these red lines so it will be clear to you to understand. And in this animation, the working of generator is very clear. Okay, this is magnet, north pole, south pole, right? And that is coil inside the magnetic field. Okay, and this is connected with the axle here, and if current is there, then you can notice the deflection in galvanometer. Now what to do to get DC current? Okay, to get a DC current, DC generator is being used. Okay, what is DC current? Actually, DC current is the current that does not change its direction with time. That is known as DC current. Okay, and for that, a split ring type commutator must be used. With this arrangement, only this is the difference. See, in DC generators, only one split ring type commutator is used, and with this arrangement, then what will happen? One brush is at all the times in contact with the arms moving up in the field, while the other one is in contact with the arm moving down. Okay, so then what will happen? Then current that is produced over here will not change its direction with time. It will flow only and only in one direction. And here in galvanometer also can be seen the deflection. Sorry, it is connected. Yes, it is galvanometer. Okay, and deflection can be seen only in one direction, right? So a unidirectional current is produced over here, that is known as DC, and this type of generator is known as DC generator. The difference between direct and alternating current between DC and between AC is that direct current always flow in one direction, whereas alternating current flows periodically in reverse direction, and then plus minus it changes between plus and minus. Okay, in picture you can see this is AC current, it is changing between plus and minus. Okay, and this is DC current, it is unidirectional, it doesn't change its direction. Okay, most power stations construct these days they produce AC. Producing of AC is easier in the comparison of DC. Okay, in India, alternating current change its direction every 1 upon 100 second. It means the frequency of AC is 50 Hertz. Why? because 50 times positive and 50 times negative. An important advantage of alternating current over direct current is that electric power can be transmitted over long distance without much loss of energy. That is a very important advantage of AC over DC. Here you can see the difference between alternating current and direct current. Alternating current are more efficient, this is first point, while DCs are less efficient. Okay, in AC's power consumption is less, while in DC power consumption is more. And cost of equipment to produce AC is less, while cost of equipment to produce DC is more. Okay, and AC has high voltage, that is why it is not safe, while DC has safer operation because it has low voltage. Okay, AC is not suitable for welding metals, while DC is suitable for welding metals. AC is not preferred for welding, while DC is preferred for welding. Any terminal can be connected to the work or electrode, while to produce DC only positive terminal to be connected to the work, negative terminal connected to the electrode. While in AC, this discrimination is not followed, right? Here, the picture of AC generator and DC generator. You can see there is only slight difference, that is split ring P and Q commutator. Only this difference is there in DC electric generator and AC electric generator. In AC electric generator, split ring commutator is not used, while in DC electric generator it is used. And here are the differences between direct current generator and alternating current generator. Okay. DC current generator produced or generated DC, while AC current generator produces AC. Okay, DC generator is used to power very large electric motors, while AC generator is used to power small electrical appliances. DC generator has commutator. Okay, AC generator has brushes and slips only. Now here are some questions. Let me read the questions for you and let me answer them. State the principle of an electric generator. Electric generator works on the principle of electromagnetic induction because here electricity is produced by rotating electric coil inside the magnetic field, right? The second question is name some sources of direct current. DC generator and cell are the sources of direct current. Question number 3 is equal to which sources produce alternating current? Okay, here is the question. So power plants and AC generators produce alternating current. Now here this is the question and you have to choose the correct option. A rectangular coil of copper wires is rotated in magnetic field. The direction of the induced current changes once in each 2 revolutions, half revolutions, 1 revolutions, or 1/4 revolution. The correct answer is half revolution. Okay. So here you can see the animation of DC generator and AC generator. Thank you, students. This was there in today's session. I hope you liked the session. Now we will meet in part 6.